Setting up a flight controller on your FPV, flying wing or any other fixed-wing airplane can be a challenge. But fear not, today we're gonna solve this challenge once and for all. Because in this video I'm gonna show you step by step how to do it. But before, let's answer two important questions. Question number one is, why the heck do I even need a flight controller on my RC airplane? Long story short, for convenience. Maybe it's not required, but the flight controller gives you quite a few of the extremely useful features that you really might use one day when flying. Trimming gets easier, flying gets easier, and when you fail safe, it will just land where you took off. And the second question is, which flight controller software should you use? In my humble opinion, choose INAV. But Paweł, there's Ardupilot, you might say. Of course, there is Ardupilot. Ardupilot is amazing, but unfortunately, to install and set up Ardupilot, you need a fucking PhD. And INAV has much lower input level and at the end flies as great as Ardupilot. So, let's go! In this tutorial we will be working with a flying wing, however every step that we will take also applies for the airplanes with a tail. The only practical difference is the mixer itself. The model I will be using is my Flybot Flags with the DJI FPV, pitot tube, Matek F765 WSE and well everything that's required to fly. Step number one is of course flashing. To be able to flash INAV to your flight controller, your flight controller has to be in the DFU mode. To put it into the DFU mode, you have two options. Option number one is to press and hold the boot button on your flight controller and then connect the USB cable. Option number two is to connect to the INAV configurator, go to the CLI tab and type DFU. In both cases, INAV configurator should detect the DFU mode and you are ready to flash. Let's go to the flasher tab. I will be flashing the release candidate 1, so I have to select unstable releases and find the target I will be using. In my case, it's the Matek F765 SE and I do want to have the full chip erased on. The safest option is always to flash with the full erase on. This way, you will be able to apply the new defaults that we are shipping with INAV on every release and to take the full advantage of the new features. Now it's time to select the firmware version. I will be using the 5.0 RC1. However, when you are watching this video, there probably is the 5.0 final. So you should choose the final. For now, let's go with the RC1. Then let's click load online. And after the firmware was loaded from GitHub, let's hit flash. After the flashing is done, the new serial port will be detected, the board will boot, and we are ready to connect. After flashing is done, let's select the correct serial port and let's hit the connect button. At this moment, it's time to decide on which platform we are installing INAV on. In our case, because this is the airplane, we have two options: airplane with a tail and airplane without a tail. Because we have the flying wing, let's select the flying wing option. It will take a moment for the flight controller to save all the settings and reboot. The next step is super important because we have to set up the board orientation and all the used sensors besides the GPS. First, let's take a look at the top bar and let's see if all the sensors were detected correctly and they are blue. Blue is good because blue means that the sensor is currently reporting the data. In our case, we have correctly detected accelerometer and gyro and missing magnetometer. By the way, if you are setting INAV on the airplane and the INAV detects the magnetometer, disable it. It makes absolutely no sense to have the magnetometer enabled on the INAV wing setup. So if you have magnetometer detected, select it to none. It will work just fine and even better. Also, barometer is correctly detected. However, the pitot tube is missing. I'm using the digital MS4525 pitot meter, so I want to select it, set the I2C speed to 400 Hz. There is no need to go above that on the airplanes at all, and let's save and reboot. And now the airspeed sensor is correctly detected. Now let's check the flight controller orientation. To do it, go to the Setup tab, take the model in your hand and tilt it backwards. If the model on the setup page is following your movement and also the nose of the model is going up, that means that you have correctly set up the orientation. If, however, you move the nose up but the nose of the model on the setup page is not following, you have to adjust the board orientation. Luckily, this is pretty simple and straightforward. All you have to do is to go to the config tab and type the new yaw degrees section. Here the rule of thumb is as follows. If you move the nose up, however the model is rising the right wing tip, then the correct orientation is 270. If you move the nose up while the model is rising the left wing, then the correct orientation is 90. If, however, you pitch up but the model is pitching down, then the correct orientation is 180. And that's all. There is no extra magic. If it's still not working correctly, try one of those settings: 0, 90, 180 or 270. If you have not mounted the flight controller on a really strange angle, it will be usually enough. Basically, the process of accelerometer calibration is to measure the readout of the accelerometer in every axis, in every possible combination, so that the flight controller can compute zeros and gains. And when this is done correctly, not only INAV will be able to compute the angles, roll and pitch, but also the horizontal and vertical translations. Because yes, accelerometer data fills the gaps between the GPS readouts. To calibrate, let's go to the calibration tab and let's take a look at the huge button Calibrate Accelerometer. During the calibration, you will have to place your aeroplane in every 6 orientations, up, down, and all the 4 sides, and keep it stable during the process. Yes, the model has to be stable during the measurements of the zeros and the gains. However, it does not really have to be super precise for the angle. Few degrees of the error will not make any difference. It's much more important that the model is perfectly still during the measurement, and that during the first step the accelerometer is facing up. In majority of the flight controllers, this means that the top side of the flight controller has to be facing up. There are a few flight controllers where the accelerometer is mounted on the bottom side of the board. Then you just have to start with your model flipped to the bottom side up. But besides that, the order is not really that important. Only the first step with accelerometer facing up. I have right now model laying flat on my bench, so let's hit accelerometer, read what it says, and let's continue with the first step. To do it, you have to hit the calibrate accelerometer one more time, then the INAV will get the zeros and the gains for this orientation, and step 1 will be done. Then let me flip the model 180 degrees so that the bottom side is facing up, and hit the calibrate accelerometer button again. One more time. Step 2 succeeded wonderfully. And now all the remaining 4 sides. And that's all. The accelerometer was calibrated. We will see the calibration finished. Success message. And here, slightly lower, we will see the zeros and the gains for the accelerometer. Now, because we are not using compass and we are not using the opflow, our job in the calibration tab is over and we can save and reboot. let's do the radio receiver and the mixer. Because nowadays INAV supports only serial-based receivers, our job is pretty easy. Let's begin with selecting the serial port to which we connected our radio receiver. To do it, let's go to the serial ports tab. Because my flight controller has quite a lot of the serial ports, the list is kinda longish. By default, the Matek F765 Wing SE comes with pre-configured serial RX receiver on the serial port 6. And by pure coincidence, this is the serial port to which I soldered my Immersion RC Ghost receiver. So I don't really have to change anything. However, in your case, you have to select the serial port on the serial port to which you soldered your receiver. Now, this is very important. You cannot assign any other function to the port to which you assign the serial RX. If you have selected MSP, telemetry, sensors or peripherals, please unselect them. Also, only one serial port can have the serial RX selected. Like always, save and reboot. After the receiver serial port was selected, let's go to the receiver tab and let's decide on the protocol we are using. Like I mentioned before, I'm using the Immersion RC Ghost, so in my case it's pretty simple. I only have to select the GHST protocol and hit save and reboot. And as you can see, my radio receiver is working and is receiving the data from the radio. Also, because the telemetry was enabled by default, I also have the telemetry from INAV flight controller on my radio. If, however, you are using something more legacy and especially S-Bus and other older protocols, this might take a moment. Mainly because someone decided that the creating of the inverter serial port protocol is a good idea. Guess what? It isn't. That means if you are using S-Bus or the F-port or F-port 2 protocol, you have to figure out not only to which serial port you want to connect your receiver, because in case of F7, H7s, you can connect them to any serial port, but in case of the F4s, which do not have the built-in inverters, you have to connect your receiver to the serial port that has the built-in inverter. On this, always consult your flight controller's manufacturer's manual. If you bought the good flight controller, it should be there. If there is no instruction manual, well, maybe this is not a good flight controller after all. Luckily, in most of the cases, there is no need to change the inversion of the serial port because INAV know what's expected, or the half duplex setting, unless you are doing something very custom. Luckily for the Crossfire, Express LRS and the Ghost, the defaults are working just like that. You can connect them to any serial port of your liking because they are not inverted and does not require any kind of the hex. But okay, assuming that you got your serial receiver working, now we have two things that we have to handle. One of them is channel zeros. If they are not close to the middle 1500, you have to go to your OpenTX radio and in the mixer tab set up the zeros so that the zeros, when you are not moving your stick, are close to 1500. There might be a small jitter, but not too much. You see, after I correctly set up the zeros on my radio, the values, the default values on all the channels are more or less fine. And now it's time to set the deadband. By default, the deadband of 5 is, well, okay for the older, not very precise radios. The rule of thumb is that the deadband should be twice as much as the average jitter. That means if our channel goes between default 1500 to 501 or 491, then we should set the deadband to close to 2. If you have 2 up or down, set your deadband to 4. If, however, you want to have a super precise feeling, you might even disable the deadband completely. In my case, I will set the deadband to 2, and that is almost all that we want to do on the receiver tab. INAV setups the default mixer based on the question on the default dialog. Because we selected the flying wing, INAV already loaded the default mixer for the flying wing, and it also gave you the information to which outputs on the flight controller you should connect motor and servos, including the left servo should go to the output S3, while the right servo should go to the output S4, and the motor should be connected to the S1. If we would load a different type of the airplane configuration, like for example V-tail with differential thrust, over here you will get the information to which outputs you should connect to which control surface, which servo. Left aileron, right aileron, left on the tail, right on the tail, and both motors, because this is the version with the differential thrust. If you're not setting up anything very custom, this is all you have to do on the mixer tab. You only have to read to which output you should connect to which servo, which control surface. Remember that if the output mapping starts to make no sense, that means that probably your flight controller cannot support the configuration you want it to do. Like, if I would want to add a third motor, you will see that there is no output to which I can connect the third motor, and the third motor will just not work. If you have the propeller on your motor, remove the propeller. Never, absolutely never test the motor running with propeller installed. Trust me, you don't want to put blood everywhere around you and visit ER and get some stitches. Not worth it. Let's go to the output tab, because it's time to making some decisions. The first decision to make is to select the ESC protocol. Every single ESC can talk with the standard one, however, it has some drawbacks. Number one, you have to calibrate the ESC, and number two, there is no ESC telemetry if you want to set it up. Luckily, almost all modern ESC can talk with the D-Shot protocol, so let's select the D-Shot 100. The speed of the protocol is not really that important. We will only use this as the propulsion, not as the stabilization, so even the D-Shot 100 is 100% fine. Do not worry about the ESC and servo refresh rates, only verify that motor stop on low throttle is on. You want to have it on because you want to stop the propeller when you put the throttle low. We also do not have to worry about idle, number of motor poles, unless you want to configure the ESC telemetry for the RPM, but you have to know how many poles your motor has, or do not worry about reversible motors if you do not want to use the motor braking. But we will not cover this at this moment. Finally, enable motor and servo output and save and reboot. Next step is to verify if the motor is working. To do so, remove the propeller, connect the battery, and then in the output tab, first you should hear the ESC beeping confirming that it's getting the signal. Then one more time with propellers off, select the motor test mode and slowly start to raise the throttle on this motor until the motor will start spinning. Do not keep it on the high revolutions for too long. This is not healthy for the motor. We only want to confirm that it is working. Next, power up your radio, because we want to do the high five test to verify if all the control surfaces are moving in the correct direction. Connect the battery, connect the radio, and start moving pitch and roll stick left, right, up and down. We want to verify that when you move the right stick right, the right control surface is going up and the left control surface is going down. When we move the roll stick to the left control surface has to go up and the right control surface has to go down. On a flying wing, when we move the pitch stick up, both ailerons should go down. And finally, when we move the pitch stick down, we want on the flying wing both ailerons to move up. At this moment, most probably one of the control surfaces, one of the servos is not moving in the correct direction. It just always does something in the opposite way. To fix it, we have to reverse this one servo. To do it, one more time, go to the output tab, find the servo that is misbehaving. In my case, this is left servo, output S3, and I just want to flip the reverse switch on this servo. After save and reboot, repeat the high five test, and now all the control surfaces should be moving in the correct direction. Let's configure GPS and failsafe. A short note, a GPS is only an optional sensor. You do not have to have GPS to have amazing flying INAV setup. However, it simplifies quite a few things. First of all, it's harder to lose your model in case of the failsafe. And second of all, it just gives you this extra confidence when flying. The GPS configuration starts in the output tab because you have to select to which serial port you've connected your GPS receiver. In my case, it's serial port 2, so you most probably will have to select in the drop-down the GPS option and leave everything else by default. However, in my case, I have the GPS that communicates over the MSP protocol, so I will have to select the MSP on the serial port 2. However, this is specific to my setup, and in your setup, most probably it will be the sensor GPS on the default baud rate. Like always, save and reboot. Now let's go to the GPS tab, and first of all, let's decide on the protocol. All the modern GPS units support the u-blox protocol, so try this one by default. However, whatever you do, try to avoid the NEMA protocol because it's really the obsolete protocol that works basically only with the very legacy modules. Yes, the u-blox module will switch to the NMEA if you really want to, but it makes no sense, so go with u-blox. And if you have M8 or newer, you might even try the u-blox 7. Then you have two options. Option number one is to select ground assistant type. You might select, you might not select. I'm usually setting this to auto and everything works just fine. And decide if to use the Galileo satellites. It makes sense if you are in Europe because the Galileo has the best coverage over Europe. I am in Europe, so I will select the Galileo satellites. I'm not usually setting the time zone, however, you might if you really want to. And finally, let's enable the GPS and save and reboot. If the GPS module was correctly connected and configured, you will see the blue GPS icon. That means that INAV is communicating with the module. It doesn't mean that the GPS module has a fix or will ever get the fix. It only means that the communication between INAV flight controller and the GPS module is working. GPS fix might or might not happen. Luckily, in my case, I have a very nice GPS 3D fix with already known position and 10 satellites tracking while inside of the building. And also the position is set on the map over here. With GPS connected, configured and working, we can go to the next step, which is failsafe. And yes, failsafe is super important. Failsafe is such a critical thing. My advice is do not overthink it. And here in the Failsafe tab, only decide if we want to drop, land or return to home. The rule of thumb is that if you have the GPS, you want to use return to home because then in case of the failsafe, the airplane will just go home, circle down and land. And when you do not have the GPS, it will be either drop or land. What's interesting, in case of fixed wing, the drop and the land procedures are very similar because while drop will kill the motors immediately but keep the servo stabilization, the land will keep the motors running for 2 seconds and then kill the stabilization. However, with the default 1000 microsecond throttle output, with the motor stop, the motor will stop either way. This is why in case of the model without the GPS, I just leave it on drop and then just try not to go into the failsafe at all. Now it's time to test if the failsafe is working. Step 1. turn on the radio. Step 2, go to the receiver tab and verify that the radio is working and that the parachute here on top is not red. Then turn off the radio and verify that after roughly 1 second, the parachute changes to red. This means that the INAV flight controller was able to detect the failsafe and will act accordingly during the real flight. Everything that we are interested right now is located in the PID tuning tab. Rule of thumb is that right now INAV comes with the PID gains that are just fine for the maiden. Then, after the takeoff, you should run the auto-tune procedure that will tune your feed forward and the rates. And that means that the initial PID setup for your INAV aircraft is super simple. In case of the aeroplanes, the only thing that you should consider is to raise the integral on roll and pitch. Those values are usually more than enough for the stable flight. However, for the maiden, for the first throw of your flying wing into the air, the integral value might be just slightly too low. Usually, I would suggest for the initial takeoff to raise the integral on both and roll and pitch to at least 10, maybe even 15 in case of the pitch, just to give the PID controller this extra level of confidence of how much and how fast it can correct for different things. CG might be off, the servo throw might just be slightly too little, so let's just give the PID controller, especially on the pitch, a fighting chance. This is also the good moment to check if the servo travel for the pitch movement is okay. If you feel that it's not enough and the servos are not really moving far enough, they are barely moving up and down, you might also, for the takeoff only and the first flights, increase manually the feed forward. This might not be optimal, but it one more time gives you the extra level of confidence during the first flight and the throw. I would, however, be careful with moving the feed forward above 90 or 100. This is maximum. Try with the more conservative values, like for example they came in, and only if you really think that okay, the servo is not really moving, raise the feed forward a little. Then you will do the auto tune and the INAV will set up the correct feed forward and rates for you. The rates setup is also super simple because the INAV will auto tune during the auto tune procedure the rates for you. The default 180 degrees per second and the 90 degrees per second should be more than fine for every maiden you want to do. And even if you will not make the auto tune, there is rather not a big chance that your airplane will be able to exceed 180 on roll and 90 on pitch. And one more time, auto tune will tune the rates for you. In case of the airplanes, there is also not need to change basically anything on the filters page. The default values or all the filters are more than enough for the airplanes. The only thing that we want to check is basically this one setting at this one point. If you have something that is equipped with the rudder, we might want to set. By default, when you bank your airplane, the airplane will turn. However, the stabilized rudder, stabilized yaw, will want to overcome this movement. But we can tell the PID controller not to correct with the rudder the slow turn after banking if we set this value. Yaw I-term freeze bank angle. When set, it will tell the PID controller not to work with the rudder if the bank angle is greater than. So the rudder will be stabilized during the level flight and not stabilized when you bank because you want to slowly turn only thanks to the banking angle of your airplane. For the beginning, it also does not make sense to set anything about the PID attenuation. We don't know yet the characteristic of the airplane. When you will feel that the flight is more nervous on the high throttle, then you might be able to set the TPA. But for the first flight, for the maiden, there is not such a need. Finally, we might want to set the fixed wing level trim. This is basically the information for the flight controller of the default angle of attack the flight controller should use when you are using angle and horizon flight modes. It's irrelevant for the acro and manual, and during the return to home, the altitude controller kicks in. However, if you are flying with the angle mode or horizon without altitude control, you have to tell the flight controller of the angle of attack you would like the airplane to have during the level flight. If you know it, fill it here. If you don't know it, I have a good news for you. INAV solves this problem. And this problem is solved thanks to the auto level. The auto level available over here in the modes as one of the flight modes is basically a modifier for the angle that tells the flight controller to automatically correct the angle of attack where angle or horizon flight modes are used. Bear in mind, auto level is not used in manual, acro, return to home or waypoints. It's only a helper when angle or horizon without the altitude control is used. Let's set up all the flight modes. All the flight modes, surprise, surprise, are located in the Modes tab. Very important note. The list of the modes you see depends on the sensors that your airplane has enabled. If you do not have the GPS configured, enabled and running, you will not see any flight mode that requires the GPS. This is maybe not that critical for the airplanes, but in case of the multirotors, no MAC or no GPS means that no position hold, no return to home, etc. Luckily, airplanes are more tolerable, and to have almost all the navigation flight modes, you need only the GPS. You never need the magnetometer, but the barometer, although technically is not required, it's a good thing to have. My setup has both GPS and baro, no magnetometer, which most probably is the most popular INAV setup. So let's just set up everything that INAV enables in this case. First of all, we have to set up the arming channel. No arming channel, no arming, well, no flying. So in my case, I'm using the SB on my radio, and the SB is assigned to the RC channel 5. By the way, it's a very good practice to keep the arming channel on the first auxiliary channel. Right after the roll pitch yaw throttle, keep the arming channel as the next one as the channel 5, which, by the way, is required, for example, by the Express LRS. So let's just add the range for the arming channel on the channel 5. By the way, I want this thing to be armed when the SB is not in the top position. That means I have to set up the range from somewhere below middle to max. Now, whenever I will move the channel B, channel 5, then the arming will trigger. Bear in mind, only setting the arming channel does not mean that the arming will happen. There are reasons why INAV might not arm, and I have the video about this topic. So check out the description about why INAV is not arming and how to fix it. If you want to increase your safety and use dual arming with 2 switches, you can do it with the pre-arm, but we will not cover the pre-arm today. The next thing I want to set up is to have the manual flight mode, because from time to time I would like to fly manual, and my switch that will decide about the flight mode will be the channel number 6, and I want to have the manual flight mode in the topmost position. So let me set the manual range, click save, and now whenever the switch, in my case C, will be in top position, the manual flight mode will be triggered. Because I'm flying always without angle and horizon flight mode, so I will just absolutely ignore them. I'm just not using them. However, from time to time I'm using the nav cruise when the INAV handles the direction and the altitude. So I want to add the nav cruise on the channel 6 middle position, because I want to have this thing on the middle position on the switch C, and because I want also in this case INAV to hold the altitude, I have to manually add the nav alt hold on the channel 6 to match the nav cruise with nav Alt-Hold. In this case, whenever I will flip switch C to the middle position, both the nav cruise and the nav hold will engage. And finally, on the bottom position of the switch C, I want to have the most popular flight mode ever, which is acro. You will not find the acro flight mode over here, because the acro is the state when not angle, horizon, any of the nav modes or manual modes are engaged. This is why here in the bottom, if you have the acro selected blue, that means in this position the acro will work. That means in my case I cannot assign any range to the switch C on the bottom position, because look what happens when I switch to nav cruise. The acro got deactivated. And because I want to have it active on the switch C bottom position, I just do not assign any mode on the switch C bottom position. The next modes I want to have configured are the position hold and the return to home. For this, we will use the switch D, which in top position will do nothing. In the middle position, it will activate the position hold, 3D position hold, and in the bottom position, it will activate the return to home. In my case, the switch D is assigned to the channel 7, so let's go find nav position hold, and on the channel 7 middle position, let me activate the nav position hold. You see, it's reacting. Bear in mind, it will never turn light blue, which means it's active, because for the position hold to become really active, you have to be arm first. Now this is only an indication that during the flight, it should be switched on. And finally, also on the channel 7, but this time on the bottom position, I do want to have the nav return to home. So when I switch the switch D to the bottom one, the return to home, when of course armed and flying, will turn on. The next two modes I want to configure are the auto tune and auto trim. I will assign them on the switch A. When in the top position it will do nothing, in the middle position it will activate the servo auto trim, and in the bottom position it will activate the auto tune. This is why in the mode tab let me find the auto tune and auto trim and assign the ranges on the channel 8, which I use to configure this, to have auto trim in the middle position and auto tune in the bottom position of the switch. By the way, today we will not cover the auto level, launch and soaring modes. They are above the basic level of this tutorial. So either check my other videos for the launch and other autos to other modes. The last two modes we will cover today are beeper and Blackbox. In my case, I decided to have both of those modes on the switch E. When in the bottom position it will do nothing, in the middle position like that it will activate the black box, and in the top position it will keep the black box running and also activate the beeper. In my case the switch E is assigned to the channel 9, so first let me find the modes beeper and the black box. They are by the way grouped in the MISC modes, and first of all let's add the range on the channel 9 on the high position for the beeper. So when I switch the switch E fully, the beeper should go off, and also add the black box on the channel 9 starting from the mid position up to full position. Save, and now we can check if the correct ranges were set. Of course, INAV has many other flight modes, but we will not cover them today. Today we only covered the basics that I think that most pilots should use. In case of the analog FPV, here in the configuration tab you have to ensure that the OSD feature is turned on. In case of DJI FPV and HD0, you have to go to the ports tab and here assign one of the serial ports for this function. function. In my case, it will be the serial port 3, and in case of the DJI FPV, I have to select the function DJI FPV VTX. However, if I would be using the HD0, I have to select the function HD0 VTX. Because I'm using the DJI FPV, I will select the DJI FPV VTX, save and reboot. After this is set up, you are basically done, and at this moment when everything is powered, you should already be seeing some kind of the OSD. If you use the analog OSD and you see some kind of the garbage on the screen, that means you have to upload the fonts. To do it, go to the OSD tab, open the font manager, select the font you would like to use and hit upload font. After some waiting, the flight controller will reboot and the OSD should work just fine. Important note, the font upload is a thing only for the analog OSD. Both DJI and the HD0 MSP display port do not use the fonts you can upload from the flight controller. INAV detects which kind of the OSD you are using, and then on the OSD tab it will only present you with the OSD elements the system you are using can render correctly. And that means that in case of the analog and the HD0 you would see all the possible OSD elements. In case of the DJI FPV you will see only elements that are rendered by the goggles directly or are accessible via the craft name element. I'm using DJI, so my list of the available OSD elements is kinda shortish, but it's just enough in the most of the cases. Bear in mind, the legacy craft name hack, when you had to put a special characters into the craft name to do some kind of the magic, is no longer a thing in INAV. Everything is configurable via the OSD tab without you having to put absolutely anything into the craft name. You can even have the craft name and a different OSD elements rendered inside of the craft name. And then you only have to decide which OSD elements you want to see and where you want to put them. It's 100 up to your needs and imagination how your OSD screen will look like. Blackbox logs are very important because the Blackbox logs are the only way to know what's going on when something is not working like expected. This is why it's very important to have to set it up and record it whenever you can, or at least record it when it makes sense. Something wrong, record a log, open it in the Blackbox Explorer and analyze what's really going on. Step 1 is to go into the Blackbox tab and ensure that the Blackbox flight data recorder is enabled. INAV supports 3 ways of recording the Blackbox logs. 2 the most popular are the internal SD card if your flight controller has the SD card slot, the internal flash memory if your flight controller has the internal flash designed to store the Blackbox logs, or in case of the flight controller without the SD card or the built-in flash, the external Blackbox recorder, which are usually the open log devices. We will not cover the open log devices setup today, but this is very simple. You only have to connect the open log to one of the serial ports and then in the ports tab assign it a Blackbox function. Bear in mind the external Blackbox recorders are relatively slow, so that means you will have to log with the lower frequency and most probably with not all the fields. Fortunately, this is not really the case for the internal SD card or the built-in flash memory. Depending on the flight controller you have, you either have to select the serial port if you are using the serial port, or the onboard SD card in case of the flight controllers with the built-in SD card, or the internal flash for the flight controllers that have internal flash. Luckily, you will only see the options that you can actually use. You also have to decide on the logging rate. Usually 1 to 1, 1 to 2 and 1 to 4 are more than enough to log enough of the data for the tuning purposes. INAV will not let you record with the frequency higher than 1 kHz. This depends on your loop time, cycle time reported here in the configurator, and the portion of the flight log iterations to log. If for any reason it's too high, it will switch to the closest one of the 1 kHz frequency. It takes a lot of data to log that often, but at the same time, you have a lot of data to work with. When your craft is already tuned and working just fine and you only want to log your longer flight, the 1 to 32 or 1 to 16 is really enough. If on the other hand you want to log the Blackbox log for the gyro flow, then 1 to 1 and 1 to 2 are most probably the best cases. Because I want to begin with the tuning session, I want to have the relatively high logging rate 1 to 2, and that should be enough for the tuning. And finally, you have to decide on which Blackbox field should be logged. Some of the fields are logged always, but some of the fields are optional and you can decide if you want to have them or not. For the tuning and the first flights, I suggest to leave them all enabled because you never know, but when you are logging the longer flights, you can try to disable some of them, but first check if the data you are disabling is not required in your case. And finally, you have to decide when INAV will record the Blackbox log. By default, if you do not do anything else besides enabling the Blackbox feature, INAV will start recording as soon as you arm. Sometimes it's desired, sometimes it's not. Luckily, you have the option to enable the Blackbox log only if one of the switches is flipped. To do it, go to the Modes tab and at the bottom of the page find the Blackbox option. And now, assign this flight mode only to the channel that is assigned to the switch you want to use to enable the Blackbox log. From now on, the INAV will record the Blackbox log only if the switch is in the correct position. A pretty nice way to conserve usually limited internal flash and sometimes even the SD card. First of all, do the high five test again. It's extremely important to have the high five test before every flight because you want to ensure not only that the control surfaces are moving in the correct direction, but also that they are moving at all. On the topics of the high five test, we had a pretty longish segment about this in the video 5 in the series, the link in the description, so just go there and check it out. If the servos and control surfaces are working nice and smooth, nothing rattles and well, moves where it should, then you also should verify if the propeller is spinning in the correct direction. But super important, never test your motor and the propeller when the propeller is on the motor. This is very dangerous. You can easily cut yourself, hurt yourself, so do not do it. If you want to test the motor, remove the propeller, check in which direction the motor is really rotating and install the propeller in the correct way. The final test, if the propeller is really generating thrust, will be just a second before the throw, when you will just arm, throttle up and check, well, if the airplane wants to fly forward or not so much. By the way, my personal advice is for the first few throws, do not use the INAV auto launch function. Yes, I know it's super cool, it's super fancy, but for the maiden flights it's actually better to limit the number of the things that can go wrong. And the auto launch is, well, another thing that can go wrong. For the first few flights, the manual throw is, in my opinion, at least, a better option. Verify that the center of the gravity is in the correct position. If it's not, you might have the interesting flight that might end up in the crash. Center of the gravity is critical. Always consult the instruction manual for your airplane, for your flying wing, on when the center of the gravity should be, and for the first flight even move it slightly forward. If you are not 100% sure that everything is fine, ask someone from your local RC community for help. They are usually very experienced pilots and they will help you verify if your model is ready for flight. Always throw into the wind, so the wind is going from that direction. That means you have to throw into the wind. And second of all, always have triple check the center of the gravity. If the center of the gravity is not correct, for example, too far back, you will have huge problems trying to fly this thing, not even saying about safe launch. The first method that works for me is the method where I hold the flying wing with my right hand relatively close to the fuselage. I have the radio transmitter, it's not on me right now, but so just imagine it's over there, on the next strap, and I can control the throttle with right hand, keep the airplane level like that, with the right hand slightly backwards, arm, throttle up to 70–80%. You rather do not want to have not enough throttle, because then there is a big chance of a stall, and not too much, because then you will have too much of the torque roll, which is also a problematic. And when the throttle is high enough, you feel that the airplane, the flying wing, wants to break away from you, you just toss it like that into the air, working both with your arm and the wrist, so that the airplane is basically always facing in the direction where you are throwing this. You do not want to give it any kind of yaw spin rotation. This is not a discus launch glider. It will not work when you will try to do something like that. You want a nice steady push on the straight line in the at least something like 20 degrees up into the air. Not too steep, because then the motor will have problem of gaining altitude and gaining velocity fast enough, and definitely not too flat, because then you will just plummet into the ground. This is not what you want. The second working way of throwing the flying wing that is especially suited for the bigger and heavier airplanes is two hands over the head. Something like that. Some people say that I don't want to put the propeller into my face. And it's a valid concern. Safety first. Please do remember that I'm not saying that you throw like that, but on the straight hands, while you keep your hands outside of the area of the propeller. Something like that. Straight hands into the air. You do something like that, and this will give usually enough of the initial velocity and also very straight trajectory, so both stall or rolling into the ground should not be a problem. However, you move it like that, and you throw over your hands, and when the airplane is reaching more or less this 20–30 degrees of the angle of the attack to the air, you release it by moving your hands outside, and it should be fine. If you are not really using a huge propeller like 15 inches, there is not a single chance that the propeller, when you hold the airplane on your straight hands, will even be close to your face. This is the 7-incher. Let's assume I have a 14-incher, so propeller would be ending somewhere over here. I still have half a meter between my face and the 14-inch propeller. Up to 10-inch, even 12 inches, absolutely no problem. There is not a single point with the throw trajectory like that, so your face is even close to the propeller. I'm Paweł Spychalski. This was the FPV University. Thank you very much for watching and, like always, happy flying!